This is how to build and maintain effective design tables. I am Joe Rousey. This is Josh Altergott, excuse me. I'm a CSWP. I'm an independent contractor. I'm based out of New Orleans. I've worked with a couple resellers with SolidWorks. I've worked with Pro Engineer. I've worked with Think Design. I've been using SolidWorks since 2000. This is my 7th SolidWorks World presenting. And this is my 2nd time doing this presentation with Josh, and I believe this is like your 5th or 6th time doing the presentation overall?
Yeah, we looked back, and I think this is the 6th time we've presented this, if not the 7th, so it's...
They keep asking to come back, and with a big audience like this, we can see why.
Yeah, exactly. I'm the support manager with Computer Aided Technology, reseller out of Chicago area. I've been using SolidWorks, much like Joe, since '98. Done a variety of different things from independent contracting to design of all sorts, and been with CATI almost 12 years now. So
older than I remember.
Exactly.
All right, this is how we're going to run the session. We're basically going to show you some information up on a PowerPoint slide, show you what it's going to look like in SolidWorks, talk about it for a second, and then we're going to pop over to the SolidWorks window and show you the actual thing. All right, so we're just going to give you the facts, then we're going to show you a quick demonstration of it. The examples we show you are going to be overly simplified examples. We're trying to show you a specific feature or a specific point, so we're not doing real-world examples, we're not getting complicated, we're just going to show you the specific topic that we were talking about. As we go through, we would like for you to bring up questions as they come up to you. If you want to raise your hand, great. If you need to shout out and yell at us because we're not paying attention to you or something, the more of a discussion this is, the better off it is for everybody. We do not have a monopoly on this information. We do not know everything there is to know about design tables or configurations. Some of you will know a couple things we don't know. Usually when we do this, we get a fact or a trick in Excel or something that we haven't heard of before. So if you want to add something to what we're talking about, please do. If you have a question, bring it up as you have it. Don't get mad at us if we defer the question. Sometimes if your question is really good, we're going to have the answer for it a slide or two later, so we might defer a question as it comes up. And the last point, when we are done, please do fill out the review sheets, the scores and the comments in there. Those are important to how SolidWorks decides what to have coming back and who to have coming back and things like that. So please put a little time into that. Anything you want to add on there?
No, I think not. If you didn't get your badge signed when you came in, please get it scanned on your way out. That'd be the only other thing.
All right.
All right.
All right, go ahead.
So our agenda for this, we will talk about what's new to configurations and design tables in 2013. They did make some changes to it, which I think are important to bring up. We're going to bring those up as we go through the presentation. We won't do those right at the beginning there. We'll talk about design tables and parts. We're going to start simple with our configuration basics, just kind of get everybody on a level playing field, so we get everybody going on that. Talk about the design table basics, the formatting, how to create them, how to insert them. Also talk about planning the design table. That's a big part of what we do here, is making sure that you plan and build it effectively. Talk about some of the execution tips, the trial and error, how to add comments, displaying dimensions, things like that. We're going to bring it all together with an example that we have of a pipe that we've used in the past. Talk about Excel and formulas and the different things we can do with that. Then we're going to talk a little bit about taking it to the next level. There's different tools that we can use now, such as the configuration publisher, and it's a great tool to use. We'll talk about the different options for that, give you a general overview of it as well. Then we're going to get into design tables and assemblies, how they're similar, how they're different to our part design tables. And the last thing that we're going to bring up is design tables and drawings and how we can incorporate all of that in there. And if we got time at the end, we'll open up for Q&A, obviously, at that point in time as well. So.
All right, we want to start off talking about configuration basics because the presentation is about design tables, but design tables control configurations. So we want to make sure everybody's on the same page with the basics of configuration. So first things first, how many of y'all are already using configurations in SolidWorks? Excellent. How many of y'all are already using design tables as well? Okay, right. Very, very good. All right, then we're going to go pretty quickly through the configuration basics. And again, we're just doing the very basics, make sure everybody's on the same page. The definition of a config is that it's a different version of the model within the same file instead of having to make a separate part file. With the configuration manager, it's going to be the third tab up at the top of your property manager. That's where the configurations will be listed. That's where you activate them by double-clicking on them. You can right-click at the top to add a new one on there, and you can edit any of them at any given time. Now, the most common things you're going to do with configs are going to be to configure the dimensions, feature suppression, and custom properties. The dimensions here across the bottom, this one's, 6 inches long? This one's 3 inches long. So you got 2 configs that are 3, 2 are 6. You got 2 of them have holes. 2 of them don't have holes. That's your feature suppression. And then the other thing you look at is that all 4 of those might have something like a different part number, and that's where you would go in and give them a different custom property.
All right. If we jump over to SolidWorks here, we'll actually open this guy up. Let's blow this thing up full screen here for us. And we'll take a look at one with no design table in it first, like we talked about. So, just to kind of talk about those configurations, like we said, you double click on any of these configurations, it switches you out to that config. You can see exactly what's going on there. We talk about feature suppression, so you can see that in the feature tree here when different items are suppressed or resolved. And each of these items, like we say, we're changing per configuration. So when we look at the overall length, we're driving that length dimension every time we make a change to this. So that's what we talk about with the configuration basics at this point in time. And so, like I said, there's our 3 inches, there's our 6 inches. So those are the things that are changing from feature to feature, configuration to configuration.
Before you pop to the next slide, I do want to point out one thing here. If any of you all are looking at this image right around in this area, or might have noticed this in SolidWorks, how many of you all are in 2013 already? Okay, so most of you probably have not seen this, or this. This is one of the new things they changed in 2013. I just want to bring it to your attention right now so you're not looking at it wondering what the heck is on their screen. We're going to talk about that a little bit later, but that is a change between 2012 and 2013. Go ahead.
All right, so design tables and parts, the design table basics, the formatting of it, it's an Excel spreadsheet that's going to control your configurations. The formatting of it, you have your configuration names are down the left-hand side, so kind of like you have it in the list inside of SolidWorks there. All of your parameters to access are across the top. So these are all your different variables that you're going to be putting in there. You have to be careful with the syntax that you put in there. We will point out where all the design table parameters a little bit later on, as well as different ways to automatically insert all these items into your design table as well. When you go back and look at the part model itself, there's not much that changes with that when you jump inside of SolidWorks with it. When we open up our other model here, this is the same model except with a design table in it. And you'll see in the configuration manager here, really the main thing that's changed is the fact that there is the little Excel symbol in front of them. There's also a tables folder that contains our design table inside of it. So those are the major changes that you're going to notice right off the bat there. All right.
Good. Okay, creating the design table. In the part model or an assembly model, if we go to the insert menu, we go to tables, we go to design table, that's where the command is found. You have 3 choices in the property manager. If you look at this image, it's on the bottom here. You have blank, auto create, and from file. Blank is exactly what it says it is. You get a blank spreadsheet, you start from scratch, you put every piece of information in there. I don't know if I've ever used that one. From file. You can make the design table in Excel outside of SolidWorks. If you wanted to, you could do it on a computer that didn't have SolidWorks on it. It would kind of be a pain because you got to get all that syntax right that Josh was talking about on the last slide, but you could technically do that, and then you could say from file, you would browse to the file location, and then you would have the option to either link to that file so you could edit inside or outside of SolidWorks, or not link to that file, and it would just end up being embedded. Now, auto-create is what I use most of the time. I think it's what most people use most of the time. And there's 2 possible ways this could work. And it depends on whether you've already created configurations or not. If you have already created configurations, so let's say we had a model and we manually created those 4 configs. If we then went to insert tables, design table, auto-create, SolidWorks would give us a spreadsheet that matches to what we would already do. It would already have the configs in there. It would already have the dimensions and the features in there. And then it basically gives us a jump start, and then we can keep adding to it. A big gotcha with that I'm not too keen on, does that laser get over there? It's going to put in stuff that you don't want. It's going to add like color, or you might not want, excuse me. It's going to put in like color or description. If it puts any columns in here that you don't want, just take them out. You don't need to have them in there. So take the shortcut of having you give you the table to begin with. If there's anything in there that you don't want to control, just take it right out of there. And real quickly before he shows you that one, if you do insert design table, auto create, and you only have that one default config, you haven't manually created any configs yet, it doesn't really know what to add in there. So it shows you this property manager that'll list out all the dimensions in the model. And you just click on any dimensions that you know you want to control, and then boom, it throws those in there for you, and it saves you a little bit of time. So with either auto create method, you save a little time. We're going to show both of them? We're showing...
We can show both of them.
Okay.
I think we got plenty of time today. Okay. So we used to only have 60 minutes for this presentation. We got a few more now, so hopefully we got enough time to do this.
Okay, so we got a copy with no configs.
All right, so here's our part. It already has 4 configurations created. We want auto create our design table. So like Joe said, insert tables, design table, and we're going to tell it to auto create. Because all of our configurations are already generated, SolidWorks is going to go through, do its thinking for us, and drop in our design table for us. What's nice about this is the fact that you do have your SolidWorks ribbon turns into the Excel ribbon up here at the top. So you have all your Excel functionality that you're used to and know how to work with. If there's things like Joe said, you aren't worried about your description or the part number, just come in here, delete those columns, they're out of there at that point in time. And we can come in here and add in any additional features that we wanted to at this point in time. As soon as we click out into the graphics area now, SolidWorks is going to go ahead, commit us into that design table format at this point in time, and you'll see all these have switched over. They got the Excel symbol in front of them now. So that's the basics right there for that one. We'll go ahead and close this out. I'm not going to save that one. All right. And here's one with no configs created whatsoever. So we have one configuration just listed as the default one there, and we're going to do the same thing here. Take the auto create, it is the default option there as well. And this is exactly what Joe's talking about. It is going to ask you what you want to control at this point in time. All our dimensions have names on it. We're going to talk about naming of dimensions later on, but I can control exactly what I want to bring in there, just holding down control, picking the different items that I want to select, say OK. It's going to populate all those different items into our design table for us. But like you said, this is kind of a basic. You don't have a lot of information in there. You got to really build on it from there. So starting off with a couple configurations ahead of time is definitely a little bit easier way to go. All right. We're going to
Go ahead.
Yes.
When you enter them the way you just did, can you also put them in order just where they will show up in the design table, or is it random?
In the design table, you can order them however you want. The issue is how they're listed in the configuration manager is alphanumeric, and you don't have a choice. And so what that kind of goes to is what I generally do is in my design table, I make them alphanumeric so that when I'm looking at my design table, I'm seeing them in the same order that I'm seeing them in the feature manager. You can order them however you want in the design table, but I get confused if my design table is ordered differently than what's in the configuration manager. Does that answer your question? Okay.
Yeah. And the same thing with the columns. The columns you can move around, so if you want your dimension 1 that's related to this whole feature that's suppressed or unsuppressed, you can order everything together that way as well. So, other question up front here?
Yeah, when you're in the sketch, you can tag certain dimensions to be included in the drawing. Can you similarly tag them to be included in the design table?
No, but that's a good enhancement request.
Yeah, the question
That's a good
is
idea.
asking if you could tag dimensions to be included in the design table like you can to include them in the drawing. And the answer is no, not at this point in time.
But I think that's a great enhancement request, and the more people who put in the same enhancement request, the more likely it is to happen. So if any of you also would like something where you could mark a dimension for design table, like you can mark a dimension for drawing, put in that enhancement request. That's a really good idea. Great.
Yeah, thank you. All right.
All right, editing the design tables in the part model. When we got the table in there, it can put in one config for us, it can put in a couple dimensions or features for us, but we got to know how to add more dimensions manually or more features manually, and obviously we got to know how to add more configs. To add more dimensions and more features, I usually point, I guess I'm using the laser pointer, we need to use this row right here. It's row 2, And you can see this has length in it, and this has whether or not the whole feature is suppressed. So when you want to manually add something, you go to row 2, and you go to the next empty cell. Don't skip any cells that could cause trouble. So in row 2, the next empty cell, that's the appropriate cell being selected. And then in the model, you just double-click a dimension. And when you double-click that dimension, that's after the fact. You're saying, okay, now put that guy in that table. Or you double-click a feature. You double-click the feature, and it puts in this syntax $state at whole is the name of the feature, and then it's either unsuppressed or suppressed. You do not need to write out the entire word. All you need is U for unsuppressed or S for suppressed. So that's the basic ways for how to add a dimension and a feature. And then to add configs, you just go down that first column, type in a new name, and then type in the values for each of the columns that you have in there, and you've got your new config. Do you want to show that, or do you want me to show it?
Yeah, you can jump in there.
Let's see if I can use your computer. All right, so which one are we using with that?
Go with the one that's already got a design table and I think is good.
Go on with old design table?
Yeah.
Just add another dimension to it.
You got it.
All right, there is a gotcha that comes up when you're adding dimensions to the table. Let's say that I want to add, we don't have the diameter in there. If I want to add the diameter of we just an extrude, right? Of the extrude in there, I need to go to row 2, I need to go to the next empty cell, and I need to double click on the dimension. What do I have to do to get the dimension to show up? Well, I could show them, but I could double click the feature, right? What's going to happen when I double click the feature? It's going into the table. So I double click the feature, it goes into the table. Okay, I'm in the next cell in row 2, I'll double click the diameter. That's in there, that's what I really want. What do I do now? I delete that column where the feature went in there. If all I was trying to do is add the dimension, I double click the feature goes in. I double click the dimension goes in. I don't want the feature, I take it out.
And this works out well in cases where you have, hundreds of features in there, hundreds of dimensions. You don't want to show all the annotations. It works out good when you're in that kind of scenario.
Right.
So.
All right, so that's adding a feature, adding a dimension to the table. Seems like you guys are pretty familiar with that already. Any questions on that one? All right. Get it back over here.
All right, so the basics of editing our design table, excuse me, you got two options. You got edit table or edit table in new window. The edit table, the table is edited in a sub-window inside of the graphics area of SolidWorks. That's what we saw. The top ribbon turns into our Excel toolbar at that point in time, and we have all of our functions in there. Downfall of that is you click in the graphics area, it goes away on you. So you also have edit table in new window. I think most everybody at this point in time is run with dual monitors. This is great because now you can open this up. It's in its own separate Excel window. You make all your changes, all your controls. When you're done with it, then you can close out of that, and it pops you right back into SolidWorks. All your changes update. Everything's there. So
the two differences, I guess I should stop closing this guy.
Yeah,
whenever you want to go to the table, it's up at the top of the config manager. You right-click. Edit table is what we've already shown you. It's what it wants to do by default. And it basically brings that into the SolidWorks window. It replaces the SolidWorks toolbars. And like Josh said, the way you close this is just to click in a dead spot of the graphic area, which is cool. It's nice, it's easy, it's short, which is a pain because you're going to do it by accident all the time. Which is why, part of the reason why, we have the option to right-click and do Edit Table in New Window. We should get a separate Excel window. Is it behind here?
there it is.
And essentially, like Josh said, if you got a dual monitor, and this is what I do when I'm working with design tables a lot, I put SolidWorks on one window, I put the design table on the other window. I can see both of them at the same time. I cannot accidentally close it. I can do everything I need to do. And then it is just as easy to close this. When you're done, you just hit the X up there. And because this spreadsheet is embedded into the part file with Microsoft OLE, just like if you insert an image into a Word document, you don't lose any data because it's actually part of the part file right there. All right, so that's edit table in new window. That's everything we need on those, right?
I think so.
Okay.
Let you talk about the options?
You got it. All right, now the options. Go ahead.
I just got a small question. Sometimes when I'm in the design table in the SolidWorks,
Yes. Let me repeat the question so that people who watch this on the web afterwards can hear it on the mic. What he's pointing out is that when you do edit table and window, and when I see it, it's usually like the second time I go into it. Is that when you see it? You do edit table and window, you work on it, everything's fine. You close the table, you come back, you do edit table and window again, and all of a sudden, all the fonts are really shrink down. They're tiny, right? They get larger on you? Okay, I've seen it go both ways. I don't know what that is. It's obviously not supposed to happen. I'll tell you what I do when that happens. Within Excel, I go in and I change the font because it seems like that's technically what's happening. It's in the background. The font is either getting bigger or smaller. So just within the table, you go into the font controls and fix it. Josh might know more about what causes it. Do you know that one?
I'm not sure. If you're using 2013, if you're on Service Pack 0 like me and Joe, where we found something the other day where they actually already fixed it in Service Pack 1, so it could have been a Service Pack issue. I'm not exactly sure, but it's something we can talk about later on as well. So. And
it's also that it's definitely the type of thing that you want to report to your reseller. And if are you familiar with SolidWorks RX? If you can record that happening with RX, then they get all the data, they get the video, and hopefully it lights the fire under their butt to get it fixed. Good question. Okay. Going into the options, when we did insert design table and we showed you the auto create example, there was a bunch of other checkboxes and options on there. We need to tell you what those are for. I'll tell you right off the bat, personally, there's one thing I don't like with the setup that they have here. There's 2 radio button choices under edit control. There's 3 options. This third option down here deals with these 2 radio buttons. I would really like this third option down here to be up here, because this third checkbox ain't got nothing to do with those first 2 checkboxes. So on this slide, I'm going to talk about the edit control and this checkbox down here. On the next slide, we're going to talk about those 2 checkboxes right there. I just personally don't like the way that's organized. All right, edit control. Allow model edits to update the design table. If that is active, you can change a dimension that's in the design table. You can change it within SolidWorks. All right, if you change that to block model edits that update the design table, then in SolidWorks, if you double click on a dimension that's in a design table, it will not let you change it there. You will have to go to the design table. Now, if you double click on a dimension and it doesn't let you change it, and it doesn't tell you why, that's not very helpful, right? That's what this checkbox on the bottom is for. If this is checked and block is turned on, then when you try to modify a dimension that's in the table, it'll come up with this message at the bottom, and it says, hey, you can't do that. It's blocked in the table. Is that making sense? Do we want to show those?
I think we can keep going.
Those are pretty straightforward, right? Everybody good with those? Okay.
All right.
The next ones we got on there, new parameters and configs. Okay. Add new rows or columns in the design table for new parameters or new configurations. Let's talk about new configurations first, because that one's a little bit more straightforward. Let's say you got a design table. You got 5 configs in there, and now outside of the design table, you manually add a new config. So now you've got 6 configs, but only 5 of them are in the table. If new configs is checked, then the next time you edit the table, you'll get a message that basically it'll come up and it'll list the new config, and if you select it and hit OK, it'll actually put that into the table for you. Okay, so it's kind of like the auto create, but it's just taking a config you put in manually and it's just throwing it into the table for you. All right, now new parameters is similar, but this is for dimensions, feature suppression, custom properties. So let's say you got a design table, you got a couple configs, and you got a dimension that's not in the design table, but you change it in 2 configs. So now you basically have a dimension which is configured differently, but it's not in the table. The next time you go into the table, if new parameters is checked, it will list the dimension right here under parameters, and if you select it and hit OK, it'll throw it in there for you. I just talked about a dimension. On this right here, this is state at a feature called crosshole. So basically somebody went into one of the configs and suppressed a feature. And then the next time you go into the table, it says, hey, that's different from config to config. Do you want to put that in there? The other example, PRP part number, that's a custom property. So again, that's just going back to the 3 basic things you configure are dimension values, feature suppression, and custom properties.
Exactly.
Any questions on those options? A big point about these options, you see them when you create the table. You can also change them at any point after the fact. If you go to edit feature on the design table, you can get these to come right back up. Right click.
Edit table or edit feature up there at the top.
Edit feature will bring up those same properties, and you can change them if you need to.
And as long as we're in here, if I just come in and add in a new config, type in our name, say OK, you'll see it's in there. It doesn't have the Excel symbol in it because it's not being controlled by the design table at this point in
So everybody
time.
see that icon is just like a yellow brick instead of the Excel symbol on there? That means it's not in the table.
As soon as I do edit table, it's going back, it's looking at it, and it's finding that parameter in there. It's listing it out there for me. I can easily click on this and have it populate inside that design table for me at that point in time. And as soon as I did that, you'll notice the Excel symbol jumped right in there for me on that one. So, all right.
Questions on the options? All right.
Very good. All right, so what can a design table control? This is a list of all the parameters that a design table can control. Obviously, it's probably hard to read a lot of what's up here on the screen at this point in time. These can be found if you go into the help menu of SolidWorks, type in the search design table parameters, exactly what it says up there. That is going to give you this list of everything. It shows you what's controlled for just parts, parts and assemblies, assemblies only, and there's even one obsolete one down there at the very bottom.
If you're working with design tables a lot, this is a great reference. It is easy to find in the help, like Josh just said, but also remember that this presentation will be available both through SolidWorks and through computer-aided technology afterwards. If you want to download this and just take these images right out of there or just print this page right here, feel free. If you use design tables all day, every day, this is a great thing to tack up on the wall of your office.
Exactly. So also, we said we'd talk about what's new in configs and design tables in 2013. Seeing as we are just there, configuring materials in a design table, parts and bodies now. For a part, we now can control the material by typing in that syntax there. Or for an individual body, we can put in the body name at the part name. The one thing that me and Joe were talking about yesterday as we were working on this is body names change. If you add a new fillet to a body, that body name is changed. So you may want to go in and manually name that body to something specific so it doesn't keep changing and it doesn't screw up your design table.
It's new, so we're not sure how that works yet, if it updates itself automatically. So we're basically giving you a little warning. If you're working with the material property for bodies, kind of double check it the first couple of times and make sure it's doing the way you want it to do. And this is basically, I haven't had time to get in and play with this yet. This is new functionality we want you to know about, but we got a little question about how one aspect of it might work. Was there a question over here?
Yes.
Okay, good deal.
All right. All right.
All right, planning for the table. Just like with the model, it's typically not a great idea to just open up SolidWorks and start throwing down lines and circles. You want to plan the thing out. You want to figure out what your base feature is, the different areas you want to work out, what the details are. Similar with the design table, you'll have a better result most likely if you plan it out ahead of time and have an idea of kind of a roadmap of what you want to do. So first things first, when possible, build the model with the configurations in mind. If you can build the model and think about, hey, what dimensions are actually going to change here? What feature might be here and what feature might not be there? That helps you kind of dimension correctly. You got a hole on a brick and it moves with respect to the left side. I'm not insulting anybody here. Don't dimension to the right side. If you need to move it from the left side, you got to dimension it from the left side. It's that simple. So I want you to plan, but it's not that difficult to plan those things. A big one is children features. Let's say you got a brick with 2 holes. Sometimes you got 2 holes, sometimes you got the left hole, sometimes you only got the right hole. Don't make the right hole a child of the left hole or vice versa. Because when you suppress a parent, what happens to the children? They get suppressed too. All right, so think about the dimensioning and what might change. Think about what features might be there when other ones aren't, and don't make them parents or children of each other. Then, how complex is the project? You want to think about how many features might be suppressed or unsuppressed. How many dimensions might be changed from config to config. How many total versions are we making? How many configurations are we making? And basically, if you have those things in mind, then you kind of got an idea of how big the thing is going to be when you're done. If you don't have those things in mind, how do you know when you're done? All right, so those are the basic things to think about. Now, is the model complete? In a perfect world, we would build the part model, finish it, and be done. And then we'd go make configurations and just change sizes and suppress features. Does anybody live in a perfect world? No? Okay. You're going to have a design table, and then you're going to add another feature to the model, and then you're going to need to get it to the design table. And that's why we just kind of talked about editing the table, adding features, adding dimensions. So perfect world, you finish the model, then make the table, but it's just not going to happen. So you're going to end up making features in the middle. Is there any swoopy geometry with underdefined curves or splines? How many of you all work with splines? Industrial design parts. How many of you all fully define your splines? That's the problem. If you're working with splines, and let's say you got an overall length on the thing, and some crazy curved shape, and you change the length, you didn't just control what happened with the shape. So if you're going to configure models that have splines in them, you need to be very careful with how you create them, and or you need to fully define all the points on there, which starts to cause a problem. So the more complex the geometry is, you're doing crazy variable section sweeps, to use a pro E term, and things like that, you might have problems configuring, and you basically need to put a little more effort into building those features and configuring them. Are there any external references to other parts and assemblies? How many of you all do top-down design, where you build parts and reference other parts in the assemblies? Not too many, but a couple of you, okay? If this happens, you need to think about configuring both the part and the assembly that they were built in, or the other parts that they were derived from. Because essentially, if part A needs geometry from part B, you can't really configure part A without configuring part B. Is that making sense? Okay, so if you're doing top-down design, you now have multiple files that you need to think about, and we're actually going to talk about something similar in just a little bit.
Exactly.
And the last thing on there, will equations be useful? I like that question because equations are almost always useful, especially when we get into configs and things like that. You can use SolidWorks equations. You can use equations within Excel, and we're going to talk about some conditional formatting and things like that in just a bit. You can end up using both. But again, this is stuff you kind of want to think about. Okay, I know I need to make this equation in this model. Where do I want to put it? Do I want to do it in the SolidWorks functionality, which has gotten a lot better the last couple of years, I think? Or do I want to use all the Excel functionality? Or do I end up using both? And again, these are just questions you want to ask yourself, stuff you want to think about before you get into it and start really tearing into it. Go ahead.
Do you have a recommendation as far as if you're going to use the design table itself?
I wish I did, but it's kind of like one of the gentlemen said in the early presentation. There's so many variations of what your model could be or what you could be doing with it that no, I don't have a recommendation to say always use one or the other. It depends on how complex the model is, how complex the geometry is. It also has to deal with user interface. If you got a team of people that know Excel backwards and forward and know all the functions and equations in there, then I'm probably going to recommend do it over there. If you know, if your team doesn't know Excel very well, but you're really comfortable with all the equations in SolidWorks, that could drive you too. So I'm sorry I don't have a good answer for that one.
Yeah, you also have to think about, how it's going to be changed later on, who's going to be changing it, what's going to be easier for them. You may not be there forever to go back and explain, well, I put 8 equations in the part and 8 equations in the design table, and if you don't update this one, then this one doesn't update. So you really got to be careful with how you set all that up.
Which brings up a good point that it would be great if we could add notes in our design table to tell other people what we did. And we can, and I don't think it's the next slide, but we're going to talk about that later.
Yeah. So other parts in planning for the design table is talking about naming. Whenever we create a part or a feature, you know how it goes. First extrude you create, boss extrude 1. First sketch you create, sketch 1. The first dimension that goes into that sketch, D1 at sketch 1. All of this is nondescript. You put 100 different features with 100 different dimensions on there. How do you know what's what at that point in time? So the best thing that you can do is go in, name them. You can see the kind of the before and the after what we got in there. Whatever features are going to be involved, go ahead and name them. You saw that in some of the other stuff that we brought up before. As we went through and looked at them, you saw the different names associated with those. So the next thing that we'll talk about here, and then we'll show you both this and the previous slide inside of SolidWorks, is dimension display. When we edit a table, we want to see the dimensions, so we can double-click on those. There's a couple different ways that we can bring that up. We can double-click a feature to just display its dimensions, but like we said before, be careful because it also adds the feature to the table. We can easily right-click on the annotations folder. One of the gentlemen earlier brought that up. And we can show the feature dimensions to display. There's also other controls in there to right-click on an individual feature and hide and show its dimensions. So we got a lot of different options as far as that goes.
All right, so what we want to talk about is the naming. You guys can see that the features are named over here as well. The features are named. And there's that warning. Actually, first things first, if I float over that, does everybody see the tooltip that pops up? It says length at pipe. That's the easiest way to know if something is named. When you select it, it'll also show up over here, and this is where you can actually type in the name. So in general, before you put a dimension or a feature into the table, name the feature, select the dimension, name the dimension right there, and that should make everything easier going down the road. And then what was the other thing?
Annotations folder.
All right, if we right click up here, we can show feature dimensions. Ooh, did we already do this one?
We might have hit some. Oh, look at that. Maybe not.
Do a forced rebuild. Oh, it's hidden. We thought that wasn't showing up. It was just hidden in the solid. Okay, when we right-click on the annotations folder and show feature dimensions, with this model, that's fine. There's only a couple dimensions on this thing. All right, real-world model, how many dimensions do you have in there? You're going to have a ton, right? When you do this, they all show up, and it can be a big, nasty mess of spaghetti, and you can't necessarily tell what's going on, which is where the other point comes in, that you can right-click on any feature when the feature dimensions are shown, and you have the option to hide all dimensions, and that should take out the diameter and the length, and that can help you kind of narrow it down to get to the dimensions you're actually looking for. I want to personally give you a big warning with this one because I mess this up all the time. If I hide all the dimensions there and then I'm done and then I just go up to annotations and turn off show feature dimensions, what happens the next time I turn on show feature dimensions? I don't see these because they're hidden. So my kind of warning on this is if you ever right-click on a dimension and say hide all dimensions, whenever you're done doing whatever you needed to do right there, go right back to that feature, right-click on it, and do show all dimensions, because otherwise you might try to show all the feature dimensions later and they don't show up. Or maybe I'd do that, give the model to Josh. He's sitting there showing feature dimensions, the dimensions aren't showing up. He doesn't know why. So be a little careful with the hide all dimensions.
You also have to know with this one too, you can only hide and show dimensions on one feature at a time. You can't multi-select a bunch of features and do hide or show. The other thing to point out here too with dimension names, I always forget about this. It started off as a system option years ago, and it is now finally per document is this little guy right here, view dimension names. Click on him, and we can actually see the dimension names on each feature in each dimension that's out there. So that's a nice way to be able to see what's named and what its name is. So just another little tip out there for us on that one there.
Questions on naming features, dimensions, or showing the dimensions? All right. Okay, couple of suggestions. You had a specific question about suggestion, and I said we can't really give you any specific suggestions. These are our general suggestions about how to approach a design table in here. First things first, start simple. Don't add too much and use trial and error. These all kind of go together for me, and it basically means this. If I got 20 features and dimensions that I'm going to throw in my table, I do not put them all in at the same time. I put in 2 or 3, maybe a feature and 2 dimensions of that feature. I configure it, and then I go and activate the configs and make sure they're behaving the way I want to. And that way, if something's wrong, I know what's wrong. It's those 2 or 3 features or dimensions, and I can fix it. But if I put in all the dimensions and all the features that I want to control and make all the configs, and then I go and activate one and something's wrong, I got a long time investigating to figure out what's wrong. So put in a couple features, a couple dimensions, make sure they behave correctly, then go in and put in a couple more, especially the first couple times you make a design table. And then after you've done it a number of times, you'll be more comfortable with how much you can put in there at a time. Saving a copy of the design table is a big one because if we make a mistake while we're creating a design table, and we'll talk about the mistakes that can be made in a couple slides, you can kind of lose everything that you did. If you bring up the table, you work on it for 5 minutes, and you make a mistake, when you close it out, that mistake can actually wipe out all of the work that you did in that session. So if you edit table in new window, or even edit table with that ribbon, before you close it, go up to File, Save As, and just save out a copy of that thing, name it with the date and the time or whatever it is, and then you've got an archived version, so if something does go wrong, you don't lose all of that work. You can copy and paste, or you can reinsert that. So that's kind of a very cautious approach, and what I kind of call that is I'm kind of doing a commentator jinx on Murphy's Law, if that makes sense. If I got the backup, nothing's going to go wrong. If I don't have the backup, it's going to go wrong.
Exactly. The other thing with starting simple as well in the trial and error side of things, I always do the min and the max, because if you create the minimum configuration, you create the maximum configuration, and those both work, everything in the middle should work. I say should because we all know what happens with that, like Joe just said. So
the last 2 points on here, the user notes. This is the comments I was talking about. A lot of times I might want to make sections where maybe these two are similar and then maybe these two are similar. So I want to put a header above those sections. You can't just go in and start typing stuff that SolidWorks isn't looking for, unless you put $user_notes. Case I don't think matters, but syntax absolutely matters. You type that in, anybody do any programming? This is a comment line. It just tells SolidWorks, ignore this. This text is for the humans that are going to read this table. And that also applies to the last point over here. Do not skip any rows or columns. As soon as SolidWorks sees an empty row or an empty column, it stops reading. All right? So maybe you want an empty column in there to separate or to add a comment or whatever. You put $user_notes right there as well. So it's basically a comment line either for a row or for a column. And again, it just tells SolidWorks, you don't read this. This is for the humans to make it easier to deal with that table.
yeah. And those user notes also work well to let other people know in the future what your intention was when you put those parameters in there also.
And that's where we might make a note that says, hey, the equation's in the SolidWorks model, not in the Excel spreadsheet or something like that. Any information that can be helpful to another user who might see it.
Exactly. All right, so the next thing that we talk about here, kind of bringing it all together, the pipe example that we have here. This is one that came from a real-world example of a consulting job that I did. Customer said, we want to configure a bunch of different pipes. We want 106 different sizes and schedules. It's not bad, it's 106 configurations. Then they add in the parameter of they want 4 different materials for each size or schedule. We're up to 425 configurations, or 424. That's somewhat reasonable. It's getting a little bit big at that point in time. Then they tell you they want each size, schedule, and material in 1/8-inch increments from 1 inch to 20 feet. Yes, you all laugh, but this is truly what happened with this. As 1,912 length configurations that you have at that point in time. You do the math, 1,912 lengths by 424 different size, schedules, and materials, 810,688 possible configurations. Yeah,
Anybody ever had a model with 20 configs start to slow down or anything like that? You want to do 810,000?
Yeah.
Nope.
Not going to happen. Your file size, everything else is going to be beyond controllable at that point in time. So this is what we say when we talk about planning it out. These are the things that you have to consider and ask the right questions ahead of time. Yeah.
Why does the size of the Excel table dictate the file, size of the file?
Because with each configuration, you're adding a little bit more calculation that can be generated inside of there. So each configuration is just adding overhead to that file size.
Recalculating every configuration, every single time. You know what I mean? Like, if you have that configuration and you're bringing it into an assembly and you're only using 5 of them, is it figuring out every?
No, it's not figuring out each one. It's just storing all of that data inside of the file. So that's where all that buildup comes in. And that's a little bit about what we're going to talk about with some of those new functionality inside of there for purging data and things like that.
That check mark and minus mark and save mark that I pointed out a minute ago addresses, it concerns the issue that you're bringing up right there. So give us a couple slides and we're going to come back to that a little bit. And just so everybody else knows and the people who are listening online know what the question was, he was talking about file size and how many configs does the computer actually have active in the memory at any given time, because I think what we're getting at is we get slowdown when we have lots of configs or when we have a large spreadsheet and things like that. You're absolutely right. They've tried to address it in this version. We're going to tell you what they did in a couple slides, and then I'm going to tell you what I hope they do again.
Quick question. I'm going to talk about it, but do these files with lots of configurations where I am. When I run into a problem is we like to put the design table on a drawing, and when you have that many configurations, you can't fit it even if you use font size like 2. You still can't fit it on a drawing. Is there any way to fix that?
It's something that we address a little bit later on as well, but there's a Microsoft limitation to that.
So unfortunately, not really.
Yeah. So.
Are you going to address what your solution was for that?
Yes, he's going to it right now.
Yeah.
Absolutely.
Yeah. So, so what we got here, kind of bringing everything together here, talk about Excel and what we can do with that. Formulas, drop-down boxes, conditional formatting, concatenations. These are all different things that we can utilize inside of Excel. If you're not that familiar with Excel, go out, take an hour-long online class or something like that. Just get some additional information on it, because there's a lot of powerful tools that you can utilize inside of here. If we jump back over here, and we'll actually open up one of these to show you the example of this. And we'll
as he's opening this up to show you what he did to make it easier to get all of those in there, I do also want to mention that part of the solution was to break it up into separate files. So there wasn't a model that had 810,000. There was something like 5 or 6 models that had 50,000 or whatever that goes to. And then in addition to that, even if you got it down to 50,000, you don't want to sit there and type in 50,000 rows. And this is where the Excel functionality is going to come in that he's going to show you right now.
And that's also we talked about saving out an Excel file and re-importing it in as a design table, the from file option. This is a perfect example where the from file was utilized over and over again, because you took one basic model, change a couple items, and then reuse it over and over again. And so what we have here, the way that this one is set up is, for example, all of our configuration names. These are all done with concatenations inside of Excel. So you can see that it's actually going through and picking out information from different cells and adding that in and populating our config names for us. There's several different things that we have set up inside of here. Our length, for example, it is configured to the previous cell plus 1/8 of an inch. And we do that for a lot of different things. Our pipe schedule here. We got a user note column here with all our different schedules. So I'm able to put in some data validation and drop-down boxes inside of there. And I'm able to pick out which one I want. And I can come in here and I have this configured in such a way that if I pick one, it updates all of them because they're equal to the row at the very top. So there's a lot of simple little things that you can go in and set up that are going to make a big impact on everything else that you have inside of there. Bottom line is, when it gets down to it, I can highlight all these different cells here, simply grab, drag down, and you can see exactly what's happening. It's generating all the sizes, all the configuration names, all the descriptions. Everything's updating the exact way that we want it to. So this is the automation side of it that you can do with a design table. So.
Please.
Yeah.
The column you have on the right-hand side there is spaced by a blank column, so it didn't technically need the $sign user notes that are.
That is correct.
You wanted to write.
And that's a very good point. And where this comes into play a lot, does everybody see what he's talking about? That in the schedule sizes, we technically did not have to put user notes because right before it, the column was empty. And like we talked about a little bit before, once there's an empty column, Solid doesn't read the rest of it. And this is great to know for if you want a playground to do equations and macros and things that you need in the spreadsheet, but you don't want them actually in the table. And this happens a lot, like here, maybe you've got 5 different drop-down lists. So you want 5 different columns over here that have these. Just leave a blank row if you know there's nothing else going to come over after that. That's a great point to make. I would also point this out. It doesn't hurt to have the user notes note in there, and there's nothing wrong with covering your butt twice.
Yeah,
with an empty column and the user
force a
notes
habit,
line.
unfortunately, for me.
Yeah.
So what can I say?
Good point. Thank you. Question over here.
You can run into a problem if you don't put the notes there. Say you wanted to add more dimensions because you added
Yes.
and you click on them on the screen. If you don't have that user notes thing, it will overwrite that column.
Okay.
It'll start writing in the empty column. It'll go to the next empty column.
And if it was populated with some numbers, whatever you have, like that schedule, sizes, all that stuff, it will start putting numbers.
Okay. Good point. Thank you for bringing that up.
All right.
Other questions, comments right now? Okay.
Good day.
Where are we at?
Somewhere about the middle.
Okay. I didn't even think about time yet.
Time, we're doing pretty good.
Okay.
11:15.
Now, this is one of the other new things in 2013. We said we were going to kind of spread these out as we get to the topics. This is the second new thing in 2013. I don't like it, but I like how SolidWorks responded when I told them I didn't like it. Here's what they tried to do. That validation was pretty cool, right? Drop-down list, you can't put in the wrong value. Everybody's going to put in the right thing. Because it is useful, SolidWorks decided to try to automate it. So in 2013, if you now make a design table, close it, and re-edit it, if you got an unsuppressed suppressed column, It changes them to all drop-down lists where you have to change, where you either select U or S. If you have dimension columns, it turns on validation, so you see a note that says enter a valid value, but it doesn't read your mind, it doesn't know what your design intent is, so even though it turned on validation, it didn't set any legal values. So you can see where I'm going with this. I'm not happy. They basically decided to automate some of your design intent. It's impossible. They can't do that. And the problem was there was no option to turn the thing off. So every time I'm making a design table and go in and edit it, I got to basically go in and turn off the validation, which we got to know how to do that in Excel. And then I close it, go back in. First thing I got to do, turn off the validation. I don't know how they got through beta testing. This annoyed the hell out of me. Yesterday, Josh and I were working on the presentation. We were going through it together. We said, we got to talk to somebody at SolidWorks about this. And we said, hey, look, there's a desk right next to us that says, talk to SolidWorks Product Development. So we went over there and we said, what's going on? And they said, upgrade to SP1. We heard you, we put in an option. In the design table options, starting in 2013 SP1, there's now a checkbox that you can turn on that basically turns on that automatic validation. So next time I do a design table in SP1, I'm turning that checkbox off. Here it is right at the bottom. Enable cell drop-down lists might be slower. So if you don't want SolidWorks to try to incorporate an unknown design intent into your spreadsheet, turn that sucker off, okay?
And if anybody who was here early this morning, you saw me take that screenshot just a few minutes ago before we started the presentation, because I still have SP0 on my machine.
Me too, and that's why we didn't know that it had been fixed. And the final point that I want to make with this is, I'm sure that we all have a gripe or two with the software. Tell SolidWorks. When there's a bug, when the tables are changing fonts or whatever it is, they are responsive. They can't always fix everything, but to me, this seems like one that somehow got past beta, and then once it was released into the wild with SP0, a bunch of people like me said, what do you think in SolidWorks? And in SP1, boom, they fixed it. So when you have a problem, report it to your reseller, or talk to the product development team here. You're here now. Go talk to the tech support people down in the partner pavilion. Tech support has a booth that they man. So if you have bugs or anything like that, report them. If you report them, they can be fixed. If you don't report them, they ain't going to be fixed.
Exactly. All right. Okay. So the next thing that we're going to talk about here is Config Publisher. Has anybody used Config Publisher at all? A couple people. All right, good. So we're hitting the right topics here then at this point in time. This thing it's a good tool. It basically creates a property manager to allow easy configuration selection when inserting the part into the assembly or downloading model from 3D Content Central. Those are the two main items for that. What we get when we generate this is similar to the property managers when we're inserting toolbox hardware. You can see left-hand side of the screen, we got configure component. That's our config publisher that we generated. Right-hand side of the screen, that's a toolbox component. Those two look identical. We built the one on the left-hand side, though. SolidWorks built the other one for us with the toolbox functionality.
How many of y'all use Toolbox now to add hardware to your assemblies? So that column on the right side looks familiar to you, where you pick out the properties.
Okay.
Before we go on into the details of this, last year we had a couple people ask us after the presentation what this was really for, so I want to be really clear about this. The configuration publisher serves two purposes. It helps you get your components into your assembly. It helps people download your components from 3D Content Central. That's it. All right, so there's not any universal reason to use this unless you're dragging configured components into assemblies a lot, or unless you have customers that use 3D Content Central to download your models. All right, now, there are two ways. Yeah, your keyboard is different than mine. There we go. All right, there are two ways to use this thing. They both use design tables, which is why it's in this presentation. One uses a design table with one line. One uses a design table with a ton of lines. We're going to go over the single line method first, because quite frankly, this is the best solution to the 810,000 possible configuration issues that we had before. Because what this does is, you set it up so all the variable possibilities are in there, and you only take the sizes and the materials that you need. Out of those 810,000 possibilities, how many do you think those guys actually use? Not even 10,000, I doubt. So, with this, you start with one line, and then as you go and you pick another size, it adds another line. You pick another size or material, or a hole is suppressed, it adds another line. And then that way, you only ever have the number of configs that you actually end up using.
Yeah.
So with this one right here, we got the one line in there. The one thing that is specific to this that you need to know about is the part number column. This can be confusing because $ part number is used in regular design tables to mean something completely different. In a configuration publisher design table, $ part number is going to be how the new config is designated. So it's basically like the name of that configuration, okay? So it's one more column over. That's the only difference there. Let's go ahead and show the example, I think, at that point, right?
All right, yeah. I'll let you jump in and show that one, Joe.
All right, let me get this one out of here.
And this one here,
Which model is it, man?
the single line design table is...
Yeah, I got it. Thanks.
The single line design table is an open-ended. You have an unlimited number of configurations that you can create with this, and that's really the point of this example here. So
It's finished. They both got it? Okay.
yeah, got it.
With this model here, and this is the one line that we just showed you here. I don't really want to add any of those extra things. We talked about that option. So the part number column is key here. And I believe we've got some validation going on in here now. Okay, so the only real Excel things we got going on are both the description and the part number. If you guys can see that, are based off of the other cells. So the sizes or material description or whatever it is. And we just have that one line in there. Now, what we do is if we right-click on the top of the config tree, we have Configuration Publisher. It's going to bring up the design table. All right, now this is the Configuration Publisher. And essentially what we have here is we can set up drop-down lists to basically select different dimensions. We could let people type in numbers for values, or we can do checkboxes. Now what will happen here, I want to set up a control, and as soon as I drag this list in here, take a look over on the right side. I can name this thing, but the more important thing is I need to tell it what do I actually want to let the user select here. So in this case, I'm going to let the user select a nominal diameter. I'm going to type in on a different keyboard than I'm used to using, nominal diameter. And I don't want to use a range from the design table. I just want to use a list, so I can go in here, and I can't remember what the values that were used, but let's go with something like 0.25, and then maybe 3/8, and then 0.5, and then maybe 3/4, and then 1. And then essentially what should happen here, if I apply this at the bottom, everybody see these tabs here at preview? If I go to preview, essentially if somebody drags this part into an assembly right now, they're going to get a drop-down list in which they can pick any of those nominal diameters that were set in there. So one big thing about this, they can't pick the wrong size. It's limited. They can only pick those sizes right there. If I go back to edit, I'm going to show you 2 of these live, and then we'll show you the rest of them in the screenshots, and then we'll show you how it works by drag and drop. If I drag in another list, this time I want to control the outer diameter. But here's the thing. The nominal diameter sets the outer diameter. Does that make sense? If we pick like a 1/4 inch, then the nominal diameter is like something like 0.13 or something like that. So what that means is that the parent of outer diameter is the nominal diameter if I select it. Those are the values for the nominal diameter, right? And this, I'm just making up numbers now because I don't know what they are. But let's say if the nominal diameter is 0.25, then the actual diameter is 0.3. If it's 0.375, then it's 0.4, or whatever this happens to be.
And you can see here that you can add in multiple values for each one as well. So you have different selections that you can get in there.
I'm not liking your keyboard and your mouse, Josh.
That's okay. After this, you don't have to touch it again. So.
Good deal. Okay, so now if I go over to the preview, this is what the user will see. As they select a different nominal diameter, the outer diameter is actually changed. Is this making sense to everybody what's going on? Okay, that's the basics of it. I don't want to kill too much time by going through all of that there. So what I want to do is come back over to the slideshow where these are the first 2 that I just showed you. Go ahead.
If you put that second row in there, then you'll get a pull down.
That's exactly right, and we're going to show you that in just a minute. You're exactly right. Good point. Okay, those are the first two that I just showed you. Now, this is kind of what Josh was talking about with multiple ones. The next one is schedule, which is a child of the nominal diameter, but there are 3 different values you can use for each one. And the last one, the outer diameter, just had one value that went to the nominal diameter. But now for the schedule, there's 3 possible values for each one. Then we have the wall thickness, which has 2 parents. The wall thickness gets its value based on what the schedule is and what the nominal diameter is. This is making sense? This is the exact setup that Josh described on that page that had all the red numbers on it that went up to 810,000. Right down to the point where, what was the last thing on there? I need this to go from 1/8 of an inch to 20 inches or 20 feet with 1/8 of an inch increments. Is that on the next page? Thank you.
There we go.
Minimum, 1. 240 is 20 feet. The increment is 1/8 of an inch. So this thing is basically set up to deal with the exact situations that we showed you with that pipe. And then the end result, this is what the preview looks like. And what I would like to do here is actually bring it into an assembly so you can see the final thing.
Actually, just pull up the one that's already got built, and you can do the preview with it that way.
I want to make an assembly, man.
Oh, you want to make an assembly? Okay, we can make an assembly then.
So the end result of this is that if I drag in, oh, it's not that one, is it? The right one. On the left side, here's the nominal diameters I get to select. That just set the outer diameter. Here are the schedules I get to select. That just changed the wall thickness and the weight per foot. And if I change this, those are both going to change as well. And I have really cleverly named my materials, material 1, 2, 3, and 4. Right down here, 1 to 20 feet, increments of 0.125, 0.88 does not match that criteria. So when I type that in, it says, no, Joe, you can't do that. I hit OK, and I come back over here and I type 1.5, which should match to that criteria. And when I hit OK, you're going to see the design table pop up. And everybody see it added in there? And added that new one. And then essentially what we've got in this assembly, we've now got this model. I'm not too keen on the name because what it actually does, and I'm not sure if this is different in 12 or not. Got to open up the actual model. It doesn't change the name of the config. What it does is it changes how the config will be listed in the bill of materials. Does that make sense? Remember that part number column that was concatenated off of all the rest of them? So it takes this default new to name, but essentially when we put this in an assembly, that's what we're going to see in the bill of materials.
So it effectively adds the configuration as their
That's exactly right. And if we think about that 810,000, we didn't make all 810,000. We only made the ones that we were actually manufacturing and assembling up to this point. That's a great point. I think you came first.
What happens whenever you have the user, they choose, but that configuration is already been made?
It just puts that one in.
Yeah, it just pulls the one that's already existing, kind of like a toolbox part does at that point in time.
Great question. I need to remember to repeat these in the microphone for the people that are listening. That question there was, what happens if you select properties that designate a config that already exists? It should just put that same config in there just like a toolbox does. Let's go over here.
Yeah, so we use enterprise.
Yes.
Like this we use for spacing. That tends to be locked down because it's a standard part. You don't want everybody operating at the same time. Are you forced to the multi-line or can you do the single line?
It comes down to, do the configs exist already or not? And that question might be better addressed with the example. I'm going to show you a multi-line example in a second, and I think that might give you an idea of which one's going to work for you. I'm thinking multi-line is going to be what you want to do. That was it? Okay. Let's go here.
So as you use this file over and over again, it slowly becomes bigger and bigger.
That's correct.
So maybe it's a good idea to save the first version as a template maybe, or
Yeah, for the potential of, as it grows, 5 years down the line, it becomes like some 50 meg file or something that's bogging people down. Yeah, for sure. It's a good idea to, to monitor that and keep an eye on it over time. So, for sure.
I'm glad that you used Lisa Pipe for this. Does this work with routing? This process?
With the routing add-in for SolidWorks, No, essentially the routing add-in is supposed to do this kind of stuff in the background for you. So you wouldn't be setting it up through the configuration publisher, you'd be setting it up through the routing setup. Yes, I'm not very familiar with routing, but the limited access I do have to it, yes, I believe those two need to be in there. However, that's a good enhancement request. For the same reason that I don't want to have to make 810 of these before I put the first one in, if we could use, and it's this, let me use configuration publisher with my routing components. And that could be, I could see how that could be helpful. Does it use the configuration names? Okay, then no. Then it ain't gonna work.
Yeah. Yeah.
But it's definitely the type of things that it can't hurt to bring that up with the developers that are here now or the support people. And even though you and I can both recognize why it won't work right now, well, if we recognize why it won't work, then hopefully we can address those issues. So I'm sorry that it ain't gonna help you out right now, but it's a good thing to try to work towards in the future.
I use routings too, and I have the same problem in that, we get a base library with those different configurations, but there are several materials that we have to use, so, and there are X number of sizes.
Yep.
So not only do we have to deal with pot, but we have to deal with those other popping components, elbows.
Yep.
Okay.
I'm guessing that's not the only issue you guys have with the routing?
It works well, but that's the biggest issue is the library configuration.
Good deal, good deal. Other questions before we show you this multi-line example here?
Can you select optional components to suppress and not suppress?
This is only for parts. It's not for assemblies.
Yeah.
It cannot be used in assemblies, but that's not a bad idea. Like if you got sub-assemblies that are going to be configured, and it would be the same type of thing where here we're suppressing features of parts. If they take the configuration publisher up to assemblies, you should be able to suppress those components, and that's not a bad idea. And that's another good one too. Is I want to use the configuration publisher with my sub-assemblies, not just with my part components. That'd be a really good enhancement request. Good question.
All right.
One more.
One more. All right.
Just a comment on that. There is a way that's complex and creative in Excel only to drive using data validation and different manual configurations into sub-assemblies and part files to drive it backwards through a design table for instance.
All right. Then you two need to talk.
Wait. I want to make sure I got that straight. You're saying that you found a way to trick SolidWorks into using the configuration publisher for assembly files, not just part files. I definitely want to talk to you after this session.
Yeah.
Absolutely.
All right. And we'll probably
And that's the type of thing where when we put in the enhancement request, we can tell them the fudge workaround that we have, and you'd be surprised how many fudge workarounds become new functions.
we call those redneck workarounds. So we'll probably we're getting a little tight on time. We'll probably hold questions at this point until the end here, but because we still got a couple more things to cover here. So the next thing that we can do here is with the config publisher is a multi-line design table. And this is when you have the full design table that already exists and includes all configurations. So this, you want to lock down everybody to use a specific set of parts and sizes of those parts. Keeps the guy from ordering the part that's going to cost you 10 times more to produce, basically is what it amounts to. And with this, you get something that's a little bit different inside of here. When we go in and we create the model, we create our full design table ahead of time. When we go in and create our config publisher, where Joe showed you before, we only had 3 options to choose the first time around. We now have every last item that was listed out in our design table.
And that was one of you guys brought that up over here just a second ago.
Yeah. So this is our design table, like we said, that we started off with. There's all the parameters at the top there. Those are what carry over into that list there. Then it's just a matter of dragging and dropping those different items into our into the config publisher and deciding which ones we want to use. The end result is this right here, and I'll actually jump over into SolidWorks real quick and grab one of these and show you exactly.
Actually, just do it in that assembly. Just drag it right into that same assembly.
Okay. Good
That's
point,
the part.
Joe.
Sorry, my bad. That's the part. My bad.
Oh, thank you. All right, so we got our missing link with the config publisher here. We drag and drop this guy in, and it, once again, we got our different parameters in here. We got our different lengths, so this is all locked down. We got our widths for each of these, our depth for each of these, and we have locked this down for each one to control exactly what it has and what it does. So I can choose a size, I can choose a width, and I can choose a hole size, and whether or not it has a hole or no hole inside of it. I need to zoom back in order for this to show everything that we got inside of there. So it's pretty simple, updates real time.
Before you hit OK, I want everybody to look at the box right above where Josh was just working. You get another option with the multi-line setup that you don't get with the single line setup. Maybe you know the config name already. You could just pick it out of that top list. Does that make sense? So with a multi-line table, you can either insert the component by config name, or if you don't know the config name, you could tell it length, width, height, no hole, or whatever it is. It gives you two choices for how to put it in there.
And you can see as soon as I pick one of those, it shows all the parameters down there and what it's doing with it as well. So it's pretty intelligent as far as what it drops in there for us. So, all right. Thanks, Joe. All right. So you want to hit this one?
All right. That's what we got for part models. We're going to move to assembly models at this point. And basically, we're going to tell you how assemblies and part design tables are similar. And then we're going to tell you what's different for assembly design tables from part models. First things first, what's similar? Custom properties, exactly the same. $PRP at property name, put in a value, no difference. Dimensions work exactly the same way. The only difference is the dimensions in assembly are going to be your mate dimensions, like angle dimensions or distance dimensions, and then reference geometry dimensions, again, like maybe an angle plane or an offset plane, something like that. Suppress and unsuppress work the same way until the very last bullet point. There's one minor difference. In parts, we suppress features. In assemblies, we suppress components, just like you were asking about with subassemblies a minute ago. What's different is in a part, when we want to bring a feature back, we unsuppress it. In an assembly, when we want to bring a component back, we resolve it. You don't unsuppress a component, you resolve a component. So that's the only difference. Technically, it's different in the background, but it's safe enough to think of it. It's just a terminology difference. You resolve a component, you unsuppress a feature. All right, and then how are they the same? This is a portion of the slide that we brought up before. All of these are properties you can put in a design table for either a part or an assembly, okay? Go ahead and hit the next one.
All right.
Okay, that's how they're the same. This is how they're different. We consider levels, and I need to be very clear about this. Level is not a SolidWorks term. It is a Joe term. It is what I use because layers is already taken by AutoCAD. We've got other things going on, so I talk about levels. We know we have a top-level assembly, right? And then we can have a sub-level assembly and then components below that. That's what I'm talking about with levels. And what we're getting at here, let's say this is the assembly I want to make, and I want to make a config that has a 3-inch post, and I want to make a config that has a 6-inch post. You can't control the post dimension from the assembly. So in the assembly, you can't say change the post to 3 instead of 6. So what you actually do is you open up the part, and you make a 3-inch config and you make a 6-inch config. And at the assembly level, you type in $configuration at component name, and then you type in the name of the configs of that part that you want. So you make configs at the part level that are the different size, and then at the assembly level, you just tell it which part config to actually use. Does that make sense to everybody? Okay, that's the big one right there.
Yeah. And the other thing with this is, too, part of the reason for doing this is you're controlling also your drawings at that point in time. You're not, if you're changing between all these different configs, you aren't messing up your drawings as well. So.
All right, so the first thing that was different was levels. The second thing that's different is instances. This is a SolidWorks term. This is the little number that shows up after your components. You put the first component in, it gets a little 1 next to it. You put the second component in, it gets a little 2 next to it. These are just instance numbers that SolidWorks applies so that it knows which one you're talking about. So in this example here, maybe I want a config that has 2 3-inch posts, then I want a 3-inch post and a 6-inch post, then I want a 6-inch post and a 3-inch, then I want 2 6-inch posts. What we do here is we type in configuration, at component name, and we just change which config of that post is in there. Now, how does it know which one? You specify the number. If you take a look at the very top up here, that's number 1. If you take a look right here, that's number 2. It's the same component name. What's different is you tell it which instance number to put in there. And very important, this gets overlooked way too much. You can do one instance at a time. You can put in a comma, and that will do instance 1 and instance 3 if there was a third instance. You could put in a dash, that'll do 1 through 3. Or you could put in a star, that'll do every instance of that component that's in there. So essentially what the differences are between assembly configs or design tables and part design tables. So in the assembly, you got to think about the level, and then you got to think about which specific instance or instances you are working on. Questions on those 2 points? Go ahead.
You already have your part level config, and then you make your other config on the assembly
Yes.
manually, and then you say insert design table. Will it already put the syntax?
If you have 2 configs in which you've changed that in the component properties, then yes, it's going to suggest that. Just like if we changed a feature dimension, we saw that it'll suggest to put that dimension in there. So yeah, if you have 2 configs you created manually, and in one config you've changed one of those instances different than the other one, then when you auto-create the design table, it'll put that in there, yes.
And that's a good point to bring up because it keeps you from having to type in all that syntax and screwing it up, because I know that's going to be the first thing I'm going to do the first time I type it in.
Especially if I'm using Josh's keyboard, which I'm unfamiliar with. Okay.
All right. Design tables and different. How is it different to part models? These are the values, once again, that are unique to just the assembly. This is the same screenshot before. We just broke out what is unique to our assembly models only. And you can see exactly what's going on in their display states, whether a component is fixed or not. So that first component you bring in, whether it's fixed, the state with its instance number, and state being suppressed or resolved.
Yep.
And
it's an R instead of a U. That's a big one that you'll see a lot. S or R in an assembly, S or U for unsuppressed in a part.
You got it. All right. So last points here. All right, we're finally catching up, I think. Is design tables and drawings. A model's design table can be shown on a drawing sheet. We select a view. We insert tables, design table. We can right-click in view, insert design table. And what we end up with is not always what we expect to see. So what we got here, going back to our original rod with a hole in it. I think that's the right one, isn't it?
That was the spreadsheet.
Is it the rod or is it the pipe that we used for that? I think it's the rod. There we go. Sorry.
Good deal.
There we go. So if I come in here, right-click on my view, tables, design table. There it goes. It drops it in the corner here for me. That's what I get. Not too cool.
Not what we want. It's got the properties across the top. It's got that user notes line in there. So getting the table in there, easy. But you got to clean it up.
All right, and that's what we talk about here, is what we see in the drawing should match what we see when we do edit table internal window. So you just want to do edit table, not edit table in separate window. When you do this, we can hide rows we don't want to see on the drawing. We can resize the sub-window to only show a portion of it. And you can see the steps here. What we start with in the drawing, what we start with in the part, how we change it in the part level, and what we see back at the drawing level.
Nice little shortcut with Microsoft OLE. I need to edit this table, which is embedded in the part. Just double-click it. It'll open the part, and it'll go to Edit Table. And again, that's the big thing. This is all about Edit Table, not Edit Table in New Window. It usually doesn't matter which one you use. This matters. You have to use Edit Table.
And this is a good point for using Edit Table in New Window for doing all of your modifications and edits, and then leaving the one that's inside of SolidWorks set up for what you're going to see at the drawing level, so you don't have to go back and hide and show different cells later on.
And essentially, we kind of set this one up already, where basically we added this user note line across here, and I'll be happy to see this part number. That will work. So essentially, I believe what I did here is I scroll up, down, so now that's everything I want to see And then I also changed the size of this so I don't get any empty cells. Now, all I see, nope, one more. I don't want that unsuppressed suppressed column. That's what I want to see on the table, so that's what I show in edit table. Close it and get back over here. I will need to do a forced rebuild, a control Q, to get everything to go back from scratch. Everybody knows about control Q, right? Good deal.
Okay.
And then that's what we see on the table. And of course we could go in, you do any of the formatting, take the lines out or make them thicker, whatever it is that you want to do. So that's the basics of getting the table on there. And then just like the young lady over here brought up earlier, there is a limitation on how big of a table you could put on a sheet. And I'm curious, are you dealing with large sheets? You dealing with like D&E size sheets or?
No, they got rid of our big plotters, so now we can only do each size. And I have found a way to rotate the table so I can at least get it this way on the 11 by 17, but if they turn it, I can't do that. And I haven't found a way to be able to make it, split it like into two columns or
Yeah, you can't split it at this point in
Can
time.
you put it on twice? Can you add it on twice?
You got it to wrap? Okay.
Okay, essentially you guys are hitting a limitation. It is, I hate to say it and deflect blame, but it is a limitation of Microsoft OLE, which these are these embedded tables, and unfortunately you guys are really hitting the ceiling, and there's not much you can do about that. That is that warning that we have up there. What are the other warnings, man?
If we double click on design table, Joe showed you before, it's going to open up the model. It's going to execute the edit table command for you automatically, just save you a couple button clicks that way. If you edit a design table and then go back to the drawing, you need to do a control Q or a forced rebuild to get it to update. You saw that when Joe first switched back over to the drawing, it was still the big, huge, ugly mess. As soon as we did that control Q, it shrunk back down to the size and shape that we wanted to see. So, all right, with all that being said, here's everything that we covered. I think we hit all the topics here. We showed as many examples as we could for all these different items. And we want to thank everybody for coming out today. Hope everybody has a good rest of the conference. Lunch is just about ready. If you want a copy of the presentation, here's the website that you go to get that. And the last one here for Joe, seeing as Joe's from New Orleans. And
We're not allowed to do sales pitches, so if you want to tell SolidWorks and tell me on SolidWorks, that's just fine. But I live in New Orleans. I think it's the greatest town in the world, and I strongly encourage you all to come down and visit. I can run down these things for you if you want, but there's lots of reasons to visit, not the least of which we got the Super Bowl in a little bit. So if y'all haven't been in New Orleans before, come on down and tell the French guys that we should bring SolidWorks World back down there. Go back one.
Yep, there you go. There's the website again.
Other questions? Good deal. Nice, Josh.
All right. Thanks, everybody.